Good morning, this is your stat sensei, Mr. Spensei, and this is a two sample T hypothesis test. The scenario is getting it done. Employees work in two different office environments, an open office plan or a private office. The number of tasks completed during a standard 8-hour workday is recorded for each employee. A workplace consultant wants to determine whether the mean productivity measured in tasks completed differs between the two office environments. All right, I see the word differ, so I need to pay attention to that. A random sample of 120 employees was selected for each. So, okay. Actually, it looks like it was 120 employees was selected. For each employee, the office environment and the number of tasks were recorded. Summary statistics are shown in the table below. So we have a sample size of 60 from the office and sample size from 60 from the private office. And we have to assume that 120, that was 60 randomly selected from this and 60 randomly selected from that. We have our average number of tasks completed for X bar 1, 32.5, for the open, 28.8. And here are our standard deviations. Conduct a test to determine whether or not employees are less productive in the private office. All right. So if we say open has more productivity than private. So that's going to be our alternative hypothesis. And they want us to test at an alpha level of 0.05. So we're going to need our formula. And our formula, we can just copy straight off of our formula chart, which is X bar 1 minus X bar 2, S1 squared plus S2 squared over both, each one over the sample size. So that's just copying our formula. But our important information is, here's the X bar 1 is 32.5. That's for the open plan. And then we have a standard deviation of 5.4, and we have 60 employees assigned or randomly selected for this. On the private, we have 28.8 tasks with a standard deviation of 4.7 right here. And then we have the sample size of 60. So let's go ahead and plug, well, actually, let's talk about our where we're centered. We're actually going to be centered on mu1 minus mu2. And the assumption is, when we do our null hypothesis, the assumption is mu1 minus mu2 equals 0. So this is going to be centered on 0 because this is mu1 minus mu2. This right here is going to be X bar 1 minus X bar 2. And we can go ahead and do that. Let's go take 32.5 and subtract 28.8. And we get 3.7. So that tells me this difference right here is 3.7. And it goes all the way to positive infinity. All right. And as we said earlier, we wanted to see if the open was greater than the private. So that would be our symbol that we're going to be using. Okay. So plugging in, we just have the 32.5 plugged in for X1, the 28.8 for X2, and our standard deviations and sample sizes plugged in. All right. Well, this is going to be a two sample t test for means. And our null hypothesis is the mean of the open equals the mean of the private. And the alternative is the mean of the open is greater than the mean of the private. Now, please remember, because this ties back into our drawing up there, this also could be written as mu1 minus mu2 equals 0. All right, because if I subtract mu2 from both sides, that's what I get. And if these were the same, if we had 6 tasks and 6 tasks, 6 minus 6 is 0. So that if they were equal, they should, when we subtract them, we should get the same thing. On the other hand, we could go mu1 minus mu2 is greater than 0 for our alternative. It's like, oh, we did 7 tasks in the open office and 6 tasks here. 7 minus 6 is 1, and 1 is greater than 0. So that's where the alternative, this null, is set here. And then when we actually subtracted our X bars, we ended up getting 3.7, and that 3.7 is greater than 0. And notice, look, we're above 0. All right, our parameters. Let mu1 equal the true population mean of amount of tasks completed in the open office. And let mu2 equal the true population mean amount of tasks done in the private office. All right, conditions. We have 2 independent random samples, all right, of 60, and those were both given. All right, so that makes that easy. So 2 independent random samples of 60, and they were both given, and we'll go ahead and check that off. And if we go 60 times 10, we get 600. And we did not give, well, we made a mistake. We did not give the population size. So we need to actually have a population size. So let's just say our population was much larger than 600. So we need to make sure that the N is less than 10%. We do know, so I don't have a way to check that because we didn't give the population size, but as long as our population is greater than 600, more than 600 people working in the open office and more than 600 people working in the private. And these are conditions for the open, and these are conditions for the private. And as long as I have more than 600 in both categories, N is less than 10% of the population. Then we have 60s greater than 30s, which is normal by central limit theorem. All right. Okay, so we need to go ahead and enter all that information into our calculator. So coming back, we go stat test number 4. Hold on for just a moment. All right, stat test number 4. And we're gonna, that's a 2-sample t-test. And we have statistics this time, and we're plugging in 32.5, sample standard deviation of 5.4, sample size of 60, sample mean of 28.8, sample standard deviation of 4.7, sample size of 60, and we said greater than, and we never pool. And we end up getting 5.288 e to the negative fifth. Please remember 5.288. Oh, excuse me, I wrote that wrong. 5.5288. I'm just going to show you that's what it was. E to the negative fifth. So 1, 2, 3, 4, 5. So I end up with 4 decimal places, which that means that's approximately 0. Because anytime we get 4 zeros, we call that approximately 0. So flipping back over, our p-value of 4.003 is approximately 0. With our p-value being 0, that's less than our alpha of 0.05. So we're going to reject the null. So our p-value is approximately 0, which is less than our alpha of 0.05. We reject the null. There's sufficient evidence to suggest that the true population, and by the way, you don't have to say difference here. The true population mean amount of task in the open office is more than the amount of task in the private office. The main thing is we need to compare the open to the private. And here's where the word more came from. We could have used the word greater here because we used a greater than sign up there. So that's where they tie together. And then, of course, as I've said before, our p-value is 0. Well, that came from right here, which is less than our alpha 0.05. That came from right there. And would reject a null, and that came right here. Then we have enough evidence. All right, so we have enough evidence to convict that the true population mean amount of task in open office, mean amount of task in open office, is greater than or more than the completed task in the private office. All right, appreciate you watching. Look forward to seeing you on the next one, and I hope this helped.